Hello, and thank you for joining this webinar where we're going to have a quick look at our low-cost automation introducing our igus robotics systems. Just a quick note, feel free to post any questions during the webinar, and we'll grab those at the end and have a little look and see if we can answer them for you. So, there are three groups within the low-cost automation product systems: drylin E, linear actuators; drylin E, linear robots; and Robolink D, which gives us the 4 to 5 degrees of freedom robotic arms. They're all based around our drylin linear systems. The E stands for electric, and as I mentioned, these come under our banner of low-cost automation. So first, a little bit of history. The igus was born in 1964 by Gunter Blaser in Germany, and he quotes, "You give me your worst problem parts and I will solve this for you." That really defined igus in terms of its future, because the idea today with our plastics products and our maintenance-free dry running systems means that we've developed into further systems using polymers, whether it be linear systems or our energy chain, to give us motion plastics. Really, that's the idea today, motion plastics. So we have the E-chain, which is for dynamic moving applications with flexible cables, and the chain that's called chain flex, and the E-chain, which is the product that surrounds that chain flex to protect it whilst moving. And then we have the dry tech products, which begins with lubrication-free bearings, plain bearings, linear systems, spherical bearings, that sort of thing. And really, it's the linear bearings that have been developed into the drive systems and linear robotics. There's always three criteria we try to meet, which is saving costs, improving technology, making sure the product is calculable online, so we have systems where products can be looked at and developed and specified with a calculable life, and of course fast delivery, which we all strive for. And so in terms of product, talking about linear robotics and normal robotics, we have the first sort of stage, which is our linear robotics and linear actuators. These are usually belt-driven or lead screw-driven, and then we add a motor to give these pre-assembled systems. The idea of having a pre-assembled system is that we can deliver very quickly. And of course, at a low cost. So to begin with, we have these standard linear actuators. And they usually come in, like I say, a lead screw system or a belt drive system. And these are traditionally for simple movements of left and right, forwards, backwards, positioning products or positioning conveyor systems, that sort of thing. So we have three sort of sizes and lengths within our standard range. These are pre-assembled, as I've mentioned earlier, so we can deliver really quickly. They have a fixed travel, again, to allow fast delivery at that low cost. This enables a customer to design and specify, and we can deliver within 24 hours. To note, there's a few little bits of technical data there. So as you can see, the smaller units have a smaller axial and radial load bearing capacity. And this means that you have the differences between the systems give you that potential to move right up to the higher load systems, and where you're trying to drive or move something with a heavy load applied to it there. Typically, applications for single axis linear actuators would be sort of 3D printing. You see on the top left, sort of a vertical axis on the machine there, and then we even have, you know, sort of museum installations or point of sale installations where you want to attract the attention of the customer coming into a shop or into an area where these units you can see here sliding up and down to reveal a product or something else to gain some interest. Applications are such wide and varied possibilities with linear actuators, especially with the igus products, because they're dry running and maintenance free, so you don't need to even consider maintaining these once they're fitted. And of course, again, going back to that calculable online thing, before you've even specified this, we can decide whether these systems will last long enough to suit the application itself. And then, of course, industry shows us food and packaging. We have this potential here as well. So varying different machines, whether it's a simple adjustment or a guarding or a door opening, closing, whatever. There's always that option for those sort of applications too. So moving into linear robots now, starting to get a little bit more complicated, a little bit more interesting. We have this system here. So it begins with a simple line gantry, which is basically a single axis movement. That's what the LG is for in that part number at the top there. So we've got DLE LG for line gantry, DLE FG, which is flat gantry, and DLE RG, which is the room gantry. These linear robots are used using our standard drylin systems, and we define them with an XY, XZ or XYZ movement. So the first one we will look at quickly is the LG, which is the line gantry robot. So as you can see, they're very simple. So you have two directions. You have the X-axis, which is the main axis, and the Y-axis. So that allows you to move in two directions, of course. So if you need to pick and place, very, very simple. And that gives you a 500 by 100 millimeter travel, 500 along the length and 100 vertically. You can see there's some load bearing capacity, so it's fairly light duty, but very, very quick potential there. So obviously the higher the load with inertia, we have to run a little bit slower depending on the application itself. Typical applications, as I mentioned, pick and place, test equipment, even pushers, you know, if you're trying to push product around, that sort of thing. Again, these are standard items off the shelf, but we do have an ability to produce these in much longer lengths, but again, it wouldn't be off the shelf, so there will be a small sort of 2-week or so lead time on something like this. Worth mentioning is the online CAD. So we have all of these systems online, ready to go, so you can get them downloaded in step format, simple PDF, fully dimensioned, and that allows you to insert those into the system you're trying to design. Very quick, so not only can you get the design work done really quickly in terms of putting them into your system, you can order online and actually they will arrive very, very quickly because these systems are on the shelf ready to go. So the second in the series of the linear robotics sort of product range is the FG, or the flat gantry robot. This gives you, it's denoted as an XY system, but actually we don't have any vertical, there's no lateral movement. So we have a standard X flat movement and Y flat movement. So standard dimensions are 300 by 300 workspace. So again, typical applications of pick and place, camera inspection systems, that sort of thing. But the load capacity is much higher, so sort of 8 times higher than the standard line gantry robot. The reason for that, of course, is because you have a more structure to it, so it gives you the ability to carry higher loads. And again, we have the CAD online, so you can download these standard systems with these standard workspace areas. Of course, as I mentioned before, there's still the ability to go for larger systems, again up to 3 meters by 3 meters, depending on the drive system, depending on the load and the speed. But there's many options there to increase your capacity in terms of movement and positioning. And the final version is the room gantry. So this gives you all the things you need. So you have X, Y, and Z movement. So you have the X and Y, which gives you much more stability and strength, and then the Y direction, which gives you the vertical or lateral movement, depending on which orientation these are positioned in. Again, if we position them in the lateral, the largest load-bearing area would be the small unit on the Z-axis, which means that that's your limiting factor. So if you turned it round and had it in a different direction, then the load bearing capacity would change. But that's something that we can work with in terms of design and that sort of thing. Again, typical applications in line linear robots is always pick and place, test equipment, that sort of thing. Really good for that. Very, very quick. and sort of multi-directional. And also you could have multi-heads on there as well. So if you had on your y-axis, you could reposition another linear slide on there if you wanted to generate a separate movement on top of that, so you could have things moving in different directions at different times. Always worth a mention, full CAD available for these too, so they're off-the-shelf items, so delivery is very quick. I must state again that you actually can get these in any size up to sort of 3-4 meters, that sort of thing, so depending on the application, of course. So this quick video here just shows the linear robots in action. That's actually in our factory in Germany, picking and placing some energy chain components. It's rotating them in the correct position, so the automatic assembly machine can pick those up and assemble the system that the pick and place robot is working on. At the other end of the scale, we have other applications, really interesting, but always a little bit strange, is this fantastic worm collection system. So this particular device has a camera on it and a small sucker on the end, and it's being developed to recognize the shape of a worm. So as you can see there, the cameras pick that up, and the line gantry linear robot comes along and collects the worm and puts it in the packaging. This would typically work within a dirty environment, of course, with the soil, but with our linear robots, they have the drylin dry bearings in there, dry running bearings, so there is no lubrication or maintenance required. At the other end of the scale, we have this very clean sort of application, which is an automatic 3D printing system, and you have beds here, 3D printing machines in batches, where they will continuously print overnight. As the things are finished printing, the linear robot will come along and collect each finished component on the tray, take it away, store it, and bring another blank tray along for the printer to begin printing again. As you can see there, it has a couple of spinning units on there as well to position within the bank of finished components. So just to recap, we have a complete modular system here using our linear drive units. We class them as linear robots, of course, because they can be programmed to position themselves wherever they need to go. And this means that you can choose pretty much anything you like to build up a system. The idea behind the units I've been talking about is that they're standard and off the shelf. But of course, as I say, the igus systems we have are modular, so they are able to be fitted together, predicted, calculated online, and designed into your machine to suit exactly what you need to do. In addition to that, we have other custom systems. All the units you can see on this diagram here, or this photo here, is actually, they are standard units, but of course we don't have standard lengths off the shelf, but they can be specified to certain lengths. The two main slides at the bottom there can be up to 3 meters long and drive up to 75 kilos. So really big systems there that can pretty much do whatever you need to do. They're very easy to develop as well. You know, once you've got the systems from our online calculation programs, you can develop your machines into suiting exactly what you need to do. So moving on, we have the more traditional looking robot, our Robolink D system. So this is also a modular system. You can see there it's sort of fitted together. It looks very simple, and it is driven by stepper motors. And we can now produce these up to 5 degrees of freedom. As I mentioned, they're very modular, so we can actually build each unit up to suit the requirements of the machine. These are the typical main components in terms of the structure. So you have a base unit here, and this gives you the ability to have underneath there, you have all your electronics and motors, and plus the drive sits in the middle here. Here we have one of the arms. This is a longer arm at the base, and then the center and further arm would give you your reach and extension. This coupling here simply joins the main pivot to the rest of the robot. So we use a very simple system, the Robolink D joint, RLD. This consists of our PRT slewing ring, as you can see here, the housing, worm wheel, worm shafts of different materials depending on the application. As you can see here, we have an example of how that would work. So typically you have good high load bearing joint with a very strong drive running maintenance free. So that consists of the Robolink D joint, and actually these can run within a wet environment also. So there's no fear of grease or whatever being washed out. These can run underwater without too much trouble. Of course, you would need to have the right kind of motor, say an IP68 rated motor, to give you the correct waterproofing that you would need. So typically we have three main types of Robolink D joints. We have the left full plastic one, the standard unit, and the high-end one. So the differences there really are the full plastic one speaks for itself. It's all molded plastic, so low cost, and probably the least accurate of the three. The standard one, which is what we tend to use on most Robolink D joints, is a good value, but also it gives you good strength and running characteristics. And then, of course, the high-end one, which gives you the really high strength, high load bearing capacity with the really high running characteristics. And underneath that, we have the asymmetrical version. So if you want to turn that PRT Robolink D joint on its side or on its back, you can fix that down and have a rotary table. And that's how the base unit of the Robolink D joint operates under this system. So motors, we also do a range of motors to fit to these joints. Traditionally, stepper motors, that's what we normally use. So they're fully programmable, either with simple brake and then system sensors on the joint, or we have full feedback through encoder systems, so the robot can be fully programmed and actually reconfigured very, very quickly and easily. We also have a range of DC motors, so for simple fixed movement, so you have a robot that wants to move in one place and back again, and that's all it wants to do, then we can use a DC motor for that. And of course, through lower loads as well, that would also apply to a DC motor. And of course, customer motors, if you want to apply your own motor, we'd need to configure a special coupling, but actually that would be possible also. Not too much trouble there. So basically, as you can see here, the Robolink D joint assembly, it's really simple. We have the RLD joint, the initiator kit, so that's where you see this small sensor here. That's to allow for the Robolink joint to know where it is. And then the motor kit here just bolts on the back via a coupling inside, fully sealed, so to allow it to operate in all environments, including dusty, dirty environments. We will hopefully have a range of high temperature units also, but the idea is that they're maintenance free, so we don't have to worry about them once they're fitted. So there's typically two sizes of Robolink D robot. As you can see on the left, you've got a little breakdown of how they look, very simple. And on the right, the two sizes, so simply small and large. The small unit would normally carry around about 1 kilo payload at full speed. Of course, if we want to run quicker or with longer arms, then the payload would change and then maybe move to a larger robot. And that would take around about 3 kilos of payload. So for simple pick and place, it's quite good. Accuracy is around about plus or minus 1 millimeter. So it gives you a good accuracy if you want to really pick and place into a small area. And the nice thing about these robots are that they're collaborative, so it means that you can have a human working next to it without risk of injury. Price-wise, typically the large robot with the basic 5 degrees of freedom would cost around about £5,000, so quite a bit lower cost than a standard desktop robot. So this video shows the Robolink D in action, and it's quite nice because it also shows the breakdown of the componentry from the inside out. So basically, you can see the worm wheel and the worm gear there broken down and in movement. So it's a really simple system. Each of these movements is modular as well, so we can change the length of the arms, we can change what type of motor we need, we can deliver it in a kit form so it can be built up, and actually when it's in operation it can be used to do a specific job and programmed to do that job, and then it can also be dismantled and then reprogrammed with one less arm or one less joint or an extra joint or whatever you need to have to enable that robot to do the job that it needs to do. So really they're multifunctional in terms of their ability to be modular and operate in the requirements that they've been deemed to do. We also have on there, you can see on the side, the energy chain system and the cabling system. That's all protected through that normal operation of energy chain cable systems with connectors, and that means that the operation of the robot is completely protected by those cable chain systems. So again, we saw some videos earlier with the linear robots in action in our factory. So this is showing the Robolink D robots just picking and placing, same job as the linear robot, but actually it's much more free to move in its picking and placing operation. It can look for any component and just go and collect it much easier than the linear robots. And actually, with a smaller space, it can sit over the side there and just pick and place the various parts it needs to. This is a loading and unloading system. So this is nice where you have a machine tool. So it just does some machining on one side of the plate there, and on the right-hand side here, the Robolink D comes in, collects the billet, and removes it. So this allows for the operator to go and do something more productive than stand there collecting parts out of the machine. So as you can see there, the Robolink is simple as well. You've only got some movement there, some two degrees of movement just to allow that to do the simple job that it's there to do. This is quite nice. It's a gantry system, a gantry robot, linear robot, with a Robolink D joint incorporated into the arm. So it's actually using all systems there. So you have the linear belt drive system, dry running maintenance free, some energy chain carrying the cables for power, and also the Robolink joint arms, but only in a lateral movement. So we haven't even got the full Robolink D robot. We just have simple joints there, just picking and placing and putting in the racking there after the machine brings up the next part. So that's a really good simple system using linear robots in conjunction with the Robolink D joints. This is actually a conveyor test system. So you can see the robot on top there, Robolink D joint robot, picking up a weight and placing it onto the conveyor at the other side, so it just travels around, and it's to test conveyor systems. So this robot, it's putting that down there, and then it travels around and just continually does this all day. So it just means that we don't have to have anyone sat there doing that job. Again, using the modular system, they also have a rotating joint here. So we have a 5th degree of freedom joint here that allows that to rotate the weight as well. So we're coming to the end now of the webinar. Target industries for our drylin linear robots and Robolink arms. Well, anywhere really, but automation, of course, machine tools, material handling, inspection equipment, 3D printing machines, all this kind of stuff where we're trying to automate and make everything a little bit leaner. That's where we come in. As I mentioned, we are maintenance free. We can deliver very quickly. Everything is modular, so it means that you can build these systems to suit exactly the requirement of the machine, and we can be incredibly reliable with that. So thanks for watching. I hope you found it interesting, and now we'll go to a few questions in a second and see if we can answer those for you. Thank you. So thank you for listening. Again, as I said, so a couple of questions here. Thank you again for those. Regarding the modular system, so we show the linear robots as a modular system. One slide shows a system on a frame. Is this something igus could supply? Yes, absolutely. So we could supply that complete gantry system on a complete frame with a cable management system and power supply. Really, whatever you need there. So that's absolutely possible. We've done that in the past, so no problems there. Second question here, is it possible to have different drive ratios for the Robolink D joints? Yeah, that's a great question actually, and yes is the short answer. So we have 3 different Robolink D joints, as you know, there's different sizes, the 20, the 30 and the 50. So for the size 20, we could have a ratio of 1:38 or 1:70. The size 30, which is the middle size, we could have a 1:5 ratio. A 1:30 ratio, a 1:50, or a 1:70. So again, a good range of ratios there. And the size 50, we have 2 different ratios of 1:48 and a 1:70. So a good selection. We can drive different loads with those. So it gives us a chance to explore different possibilities. A third question here: what are the arms made of? So the Robolink D joint arms, there was one slide there I showed with the different configuration, a very simple configuration, but they are actually a folded steel, powder coated, but actually we can do those in a plastic as well. We're working on that at the moment to try and reduce the overall weight of the robot and to reduce cost, and of course to make things a little quicker. We can reduce inertia via that avenue, then that means we can move around a bit quicker. And actually the payloads we're talking about, plastic is perfect for that. So that was the 3 main questions. I did have one slightly off-piste question, which was about if 2 sliding components are to be machined to interact with one another, can the same igus Drytech material be used for each component? So those of you that know igus know we make a range of dry running plastic polymer materials for all our linear products and our plain bearings as well. So the best way to have 2 sliding components running together if they're plastic is 2 dissimilar plastics. So if you were to take, for example, our Iglidor J material, which is a low friction material, and then run a slightly harder material against that, that will give you 2 suitable running surfaces and actually give you a nice low friction as well. But if you have the two plastics the same running together, it can sometimes lead to a little bit of stick slip and that sort of thing. So always ideal to run 2 sliding components of dissimilar materials. And that's it. That's the questions I have. So again, thank you for listening. I hope you found it interesting and useful. There will be more webinars following, so we'll keep you posted. And thanks a lot.